This is the summary for lesson 7, all, some, or no solutions. And so throughout this lesson, what I've done is I've tried to add a visual element to looking at these problems, to looking at these solutions. And so in the first part of this summary, they use this equation 2x equals 6. And they say this is true for x equals 3, which is correct. 2 times 3 equals 6. But if you replace x with 4, you get 2 times 4. That does not equal 6. That equals 8, actually. So 3 is a solution to this equation because there's only one number, that 3, that you can double to get 6. Another example, in this equation, no matter what value you choose for x, it will always be true because 2x is equal to x plus x. So if you add a number to itself, that's always going to be equal to double that number. So for all values, this is true. All values of x, this is true. So whatever it says right here, if you double a number, that will always be the same number as adding the same number to itself. And finally, you can have equations where there are no solutions for x. So x is never equal to x plus 1. You can't make those equal because you take some value and you add 1 to it. It can't be the same as the original value. It cannot be true. And finally, they say that as you simplify equations, you might get something like this. 8 is equal to 7, and that's clearly not true. So again, in that case, there are no values that are a solution to the equation. So this statement is false, so it must be that the original equation has no solution at all. They're not really showing you the original equation. And it says here, when we try to solve the equation, we make allowable moves. So what does that mean? Well, that means that you're using the properties of arithmetic or the properties of mathematics, such as the distributive property, the commutative property, the additive inverse, the multiplicative inverse, trying to keep both sides balanced as you work through them. And you combine like terms, and eventually you end up with x equals something, or some number is not equal to some other number, or x equals x. You get the same values on both sides. So let's take the first example from the first page, 2x equals 6. If I graph the left side, y equals 2x, that has a slope of 2, and it crosses the y-axis at 0. This is 2x plus 0 out here. So this is the graph of the left side. And the graph of the right side, we've only seen a couple of times, but this is y equals 6. So no matter what the value of x is, y is always 6. So you go out here, x is way out here, y is going to be 6. So this is the graph of y equals 6. Y is always equal to 6. So this is the same as y equals 0x. So 0 times x plus 6. So it has no slope, and it crosses the y-axis at 6. So where does it intersect with the line y equals 2x? Well, out here at the point 3, 6, because 2 times 3 equals 6. Now the point 4, 8 is up here. 2 times 4 is equal to 8. So that's not on the line y equals 6. So this is not true, whereas when x equals 3, it is true. It's the point where these two lines intersect. The next equation that they have is x equals x plus 1. So there's no solution for this. There's no value of x that can make this equation true. So if I graph each side separately, I get y equals x, this one right here. So 7, 7. So if I go out, if x is 7 units, y is 7 units. But if x is 7 units out here, y is 8 units right here. So if I add whatever value I choose for x, for this line, I'm always going to add 1 to that. So y is equal to x plus 1. So this line is always going to be moved up 1 unit compared to the first line, y equals x. So x plus 1, always 1 more than x, can never be equal. You can never have these two lines together. They're never going to cross. They have the same slope. They're never going to intersect. There's no point that is shared between them where x, they have the same value of x at this and y at the same time. There's no point that they intersect because they are parallel lines.